Hi, good morning, guys. How are you today? It is April 15th, tax day, originally. I hope you guys are doing all right. And I want to first of all say great job on the test. Guys, you really did a great job. And I think you're really learning what we're doing here, and I'm really proud of you. And I know it's tough for all of us, but just keep it up. Keep it going, and you're going to be doing great. My goal is to help you learn this algebra too. I know it's a lot of procedures right now. It's a lot of details, but you're going to get all set for next year. You'll be ready to go. And I want to know if you have any computer issues whatsoever. Please let me know. Sometimes you be in the middle of something and something goes wrong. Power goes out. Your internet connection just goes away, and you don't get a chance to finish it properly. Just let me know. I can always reset things, and we can take care of it on my end. And if you're really having super connectivity issues, we can even do alternate things. Just let me know if you have any trouble with anything. We'll take care of it. Okay. Well, we're continuing our chapter 6. This is the next to last session. Let me try that again. The next to last section. Okay. And this is about rational exponents. Now, what is a rational exponent? Well, what's a rational number? Yeah, it's a number that can be written as a fraction. That's a rational number. That's a rational number. That's a rational number because you can write it as a fraction of two whole numbers. And that's the key people don't mention. It can be written like a ratio or a fraction, but it has to be of two whole numbers. And that's where the word rational exponent comes from. It's a ratio. Okay. So you might be thinking, somebody might say, well, isn't this a fraction, pi over 3? Well, no, because pi is not a whole number. So this is not a rational number. So rational numbers are any numbers that can be written as ratios with two whole numbers. Okay. That being said, oh, one more thing, a rational exponent. What if I took x, any number I want, and took it to the 1/2 power? Okay, here's the big thing. This is what it means. It means that this denominator is your root. This would be your exponent. Now, we never write the 2 for a square root, and we don't, anything to the first power is itself. So x to the 1/2 is the same as the square root of x. Now, that's going to continue and be true for any rational number. So I'm going to give you the generalization. X to any fraction is written like this. The denominator is the root. The numerator is an exponent. This right here is really what we're doing in this section. Now you're going to see some examples where I think it's going to become super clear. So I'm going to ask you to write these in the other form. If they are rational, let's write it as a radical. And like these, if they are radicals, we're going to write them as a rational. So here's what I mean. 5 to the 1/3 equals, the denominator is 3. Exponent is 1. It's the cube root of 5. That's all that it means. Okay? What's 6 to the 2/5? The denominator is your root. And your numerator is the exponent. So you can think of it like that. What is 6 squared? It's 36. But these are both the same. This is how it works. M to the 4/7. 7 is your denominator. 4 is your exponent. Now, before we do that, remember when you take a power to a power, what do you do with these two exponent rules? Is you multiply them. What's 3 times 2/5? I know, it's 6/5. Now, how do I turn that into a radical? The 5, the n, the 6. Now, a little note here on the side. This is correct. This is what I would expect you to do. However, that sixth could also be here, the whole thing to the sixth power. It really means the exact same thing. These two mean the exact same thing. Now we write it like this because it's easier to write, but there'll be some cases where this might be easier to calculate. And we'll get to those if we need to. All right, turn this back. Now we'll do it the opposite way. The square root of 79. There's no number there. We assume it's 2. It's a square root. It's 1/2. 153 to the fourth. I'm sorry, the fourth root of 153. So it's 153 to the 1/4 power. That's it. It's pretty much just definition here. All this goes to the 1/3 power. So all of it, 27, m to the sixth, n to the fourth. There we go. And it all goes to the 1/3 power. Now, that's how you rewrite it. Now, if you can simplify it, that'd be great. So do you know 27? How do you rewrite 27? Do you remember? Or not remember, but how do you break it up? 3 times 9, 3 times 3. Isn't 27 3 to the 3rd power? Now all these inside are going to the 1/3 power. Remember, when you take a power to a power, you keep the base the same, you multiply the powers. So what's 3 times 1/3? Well, it's 1. What's 6 times 1/3? What's 6 divided by 3? Well, that's 2. Oop, that's supposed to be m. And n to the 4th. 4 times 1/3. Well, that's just 4/3. Nothing much you can do with that. So it'd be 3m squared n to the 4/3. All right. Put these up there too. The 5th root of this. Let me get rid of this. So the 5th root would be, we'd have 2 a to the 10th b all to the 1/5, and then we put each part in. So 2 to the 1/5. Well, you can't reduce that at all. That's just what it is. Oh, 10 times 1/5. So remember, multiplying by a fraction is easy. Multiply the top, divide the bottom. 10 times 1 is 10. 10 divided by 5 is 2. And b to the 1/5. So that's how you write these. That's the idea of what this is. If you've got a rational exponent, you can rewrite it as a radical. This is a very helpful tool in solving equations, which is actually the next section that we're doing. So first, we're going to solve, just simplify expressions. 81 to the 1/4. What does that really mean? Well, that means the 4th root of 81. Now, you might know what the 4th root of 81 is off the top of your head. And if you guess 3, you're correct. And if you did not guess 3, well, just break it down. 9 and 9, 3 and 3. Isn't it really 3 to the 4th power? Which is 3. Or think of it this way. It's 3 to the 4th power to the 1/4 power. Remember, these two are exactly the same. And what's 4 times a 4th? 1. So your answer is 3. It doesn't matter, because now you have choices. It doesn't matter if you think about this as the 4th root of 81 and solve it, or think about this as a rational exponent and solve it. They both turn out to be the same. You can do either one. It's up to you. 1024 to the 1/5. I actually happen to recognize 1024. I know what it is. I know that it's 2 to the 10th power. Now, it's just because I work with binary, at least I used to. So those numbers are familiar to me. So I know this is 2 to the 10th power to the 1/5. Now, If you don't know it's 2 to the 10th power, well, you just do this. And you just start breaking it down. And I recognize 256 as the square root of 16, or the square root of 256 is 16. I recognize that. And I know that these are true. I know that all these 4s break down to 2s. So if it's helpful to do this, do it. So you think you get 1, 2, 3, 4, 5, 6, 7, 8, and up here you had 9 and you had 10. You had 2 to the 10th. Well, now use your just basic multiplying skills. Power to a power. What's 10 times 1/5? 10 times 1 is 10. 10 divided by 5 is 2. This turns out to equal 4. All right. That's what we got. Here, 8 to the 5/3. So I don't want to say the best way to do these, but there's different ways to do them. Like, do you recognize 8? Can you break down 8? I know that 8 is 2 cubed, because 2 times 2 times 2 is 8. So if you multiply, 3 times 5 is 15. 15 divided by 3 is 5. Or, doesn't matter the order, 3 divided by 3 is 1. 1 times 5 is 5. It's 2 to the 5th. And I happen to know that 2 to the 5th is 32. That's the answer. That's evaluating that expression. We're going to evaluate some more. And then we'll end this video after that. And, that'll be your first part of this. So we want to evaluate negative 256 to the 3/4. Now be careful of the negative, and notice where the position is. And look at these two, 12 and 13. The negative is not included inside the parentheses, so the negative is not going to the 3/4 power. The negative is on its own. The 256 is going to the 3/4 power. Now, like I told you, I'm good with these numbers now, especially with factors of 2. I know that this is 2 to the 8th. And again, if you had a calculator, do you need to even know it's 2 to the 8th? Could you do 256 and raise it to the 3/4 power and get an answer? You could, if it's a whole number answer. Otherwise, it would give you a decimal. So you can do that if you'd like to, but I also like you to make sure you're aware of how to do these without a calculator. So if you don't know 256 is 2 to the 8th, remember we kind of just did this problem on the page before. Remember it's 16 times 16, and each of these 16s break up. Oh, I did it again. Don't know why I always do that. Each of these 16s break up into 4 times 4. And each of these 4s breaks up into 2 times 2. So I have 1, 2, 3, 4, 5, 6, 7, 8. All right? 1, 2, 3, 4, 5, 6, 7, 8. That's why it's 2 to the 8th power. And once I know that, now I just multiply. Multiply by 3/4. So 8 divided by 4 is 2. 2 times 3 is 6. So it's really 2 to the 6th power. And what is 2 to the 6th power? Let's see. 2, 4, 8, 16, 32, 64. Two to the 6th is 64. So this becomes negative 64. Oh, can I see how it works? Now let's do one with a negative inside the parentheses. I know that 64 is 2 to the 6th because we just did it. That's helpful. Now we're going to deal with the exponents. How do these exponents change? Remember, the negative 2 is in the parentheses. The negative stays inside. Now how the exponents change. So 6 raised to the 2, 2 to the 6th raised to the 2/3. We multiply 6 times 2/3. We get 12 over 3, which is 4. And just be careful, it's the whole negative raised. Negative raised to an even power is going to become positive, because negative 2 times negative 2 times negative 2 times negative 2 is 16. Alrighty. And if you think about it from the beginning, that top exponent is 2. I'm going to be squaring this thing anyway, and a negative number squared is going to be positive. So the whole time, we could have realized our answer was going to be positive. So just think about those things. Let's do one with the same base. This is nice. The same base means we just add the exponents. Remember, when you multiply with the same base, you add the exponents. This is just 27 to the 1/3 plus 4/3. Well, that's a nice easy one to add. It's 27 to the 5/3. But we're asked to evaluate, so there's probably more we can do. Well, what is 27? 9 times 3, and 9 is 3 times 3, so 27 is also 3 cubed. And we just raise that to the 5/3 power. And when you raise a power to a power, you multiply. 3 times 5/3 is 5. Because 3 divided by 3 is 1. 1 times 5 is 5. And 3 to the 5th power happens to equal 243. I kind of know that one. And I did do it just beforehand, so I double checked it. But it is 243. You have a calculator. Please use it. I want you to know how to manipulate these to get the right answers. You could put all these in your calculator and get the right answer, but make sure you know how to do them. All right? So that concludes the video for the first part up to number 14. So I'll catch you at the next video. Bye.